Okay? A summary of graphing. I'm going to give you a list of steps to do when you have to graph either a rational expression or a polynomial. And that's what you're going to have in the test. You're going to have a rational expression and a polynomial to do to graph on the test. All right? I'm going to ask you various questions. That's today. November 17th, Monday. We're going to do max min, and we'll do whatever we need to do for the differentials, although that is not an important topic. The max min is. But I'll have to see what's covered in WebAssign for differentials. I don't know what the heck I have on there, but we'll see. Differentials are not on the test. There will be 2 max-min problems on the test, however. Okay? 2 graphing problems and 2 max-min problems on the test. Okay? That will finish the chapter 3. November 20th, next Thursday, we're going to do a lab and review.
Oh yeah, are you going to post the lab, the new lab?
What's that?
Are you going to post the new lab?
Yeah, I need a new lab 4, huh?
You can do limits. It's great.
I don't know if I want to do limits, but we'll see. I'll do another lab, or maybe we'll do limits. No, I'll make up a new a max-min problem.
Did you not like the limit one?
I didn't like the limit one. And I'd rather have you do a max-min problem, I think. So I'll make up one. All right. But we'll see. We'll see how that looks out, how that works. Lab and review on that Thursday. During the review, I'll give you a sample test. I have one made up. And I'll pass it out to you. You're going to work on the sample test, and then I'll go over it like we did the last few tests.
So
Okay?
the test is 2 graphing questions and 2 max min?
So far, here we go. The whole test is going to be mean value theorem first. Then it's going to be 2 graphing problems. And then 2 max-min problems. I believe that's the whole test.
That's test 4?
That's test 4, our last test.
5 questions?
Well, there's basically 5 sections. The mean value theorem will be like, here's a function, find the derivative at c, find where c is equal to f prime, or f of b. Yeah, there'll be several questions, yeah. The graphing problems will be several questions. When I give you a rational expression, I'm going to ask for vertical asymptotes, I'm going to ask for horizontal asymptotes, I'm going to ask where it's increasing, decreasing, concave up, concave down. There's like 6 questions for each of the graphing ones. But there's basically 5 parts to the test. Mean value theorem part, 2 graphing parts, and 2 max-min parts.
Sweet.
4. Yep.
25.
20 questions.
Oh, yeah.
25 and a final. November 24th is your test. It's your last test, test number 4. Okay, that's on the Monday of Thanksgiving week. Okay, obviously don't meet on the Thursday of that week. You'll probably take the test and leave when you're done. Okay.
Give us the grades.
Yeah, I'll give you the grade and say see you later.
I don't know.
Then, next time we meet is December 1st. I'm going to review for the final. I'll go over the test, okay? Go over test 4. And I'm going to tell you the topics on the final. Okay? I'll tell you more or less how the final is set up.
December 1st, right?
That's December 1st. Okay? That's a Monday after Thanksgiving. December 4th, we will do a sample final. Okay? I'm going to pass it out to you guys. You guys will do it. You bring it up to me. I will correct it. If you do well enough on that, you can be done.
Or we can take it again.
Or, yes, you can take it again. Or you can come back December 8th and take it again.
What
Okay?
if you just take the sample final and you get, for example, 80?
Okay?
Can you just take that grade?
Yes. If you get a grade you like on that from that sample final, take it. If you don't, come back to next week.
Sample final and final the same thing?
Pretty close. 25 multiple choice questions, very similar. I will change the questions around.
75 or something on the sample?
What's that?
We have to get like over a certain amount to not.
Not really. It's not like some of the other courses where you have to pass the final to pass the course. But obviously, if you fail the final, you want to take it again.
Yeah, that's what I'm saying.
Yeah, because it's 40%. I believe I have 40% of your grade is the final. 40% of your grade is the hour exams, and 20% is the homework on WebAssign. I believe that's how I have it.
40% of your grades final?
Yeah,
So,
it's big.
so
Fail
say,
the final, fail the class.
so say like, we got a bunch wrong, do you mark which ones are right and then we can study that again?
Yeah, you'll come up to me, I will correct it. I will give it back to you. When everybody is done, I'll go over it, okay? So I will go over it, and you will have it in your hand. And then the next class, that December 4th is what, a Thursday, I believe, and then the December 8th is a Monday. It'll be a very similar final. Questions will be very similar to what you had in the sample final, but they'll be slightly different.
What's the last day of the semester?
For you guys, it's December 8th.
It's like the 15th or something.
Yeah, day school goes pretty late. Day school has the finals after this. Last day of classes is December 10th, I believe. And then there's finals after that.
Oh, man.
Yep. All right, there's the rest of the semester then, okay? All right, so today we're doing the summary graph, but I will take any questions you have on anything first. You got some? All right, let's take a look.
It's a big one.
What's that?
Doozy.
It's a doozy.
It's a doozy?
Oh my
No.
gosh.
No.
And one of the ones that we did last week, I put in the answers and it was wrong on one side. Remember one of them, we were coming up with like 6.1 and, it was like negative 6.1 and like 9.5. We were coming up with decimal ones and I should have brought it in. I
Yeah.
had it in my purse.
That was one that we derived even though it wasn't asking. It was asking for the second derivative and we did like the first derivative and anything to help explain it to Danny.
I can't remember exactly the circumstances. If you
Is that
want,
the one I used Mathematica to solve?
oh
Or
yeah,
no,
yeah.
that was this one.
Was it a mess?
Oh, no, yeah, that's what you're talking about. That was the, 4x cubed. That one.
Minus 9x squared,
Mm-hmm.
minus 15x.
Yeah, because that one wanted to know the point of inflection.
Yeah, that was it though. It was only that one point it needed, right? I
Right.
thought, or something like that.
Yeah.
And then we had that.
No, it was the 4 sine x plus 4 cosine x.
That one we did. Yeah, I was up there, and I
It was
thought,
weird numbers.
3 pi over 4 and 7 pi over 4.
yeah.
Which one are we doing?
Right now we're doing something else. But listen, just If you got some-
the real number, then it might come out weird. But it's supposed to be 3 pi over 4 and 7 pi over 4.
yeah, and that was right. That's the
Points of inflection, yeah, x equals 3 pi over 4 and 7 pi over 4.
That's right. We had to get them in the right quadrants, the second and the
Yeah.
fourth, or
Smaller
whatever.
and larger
Because
values.
it's tan x equals -1, so where
Yeah.
x is -1.
If you want, send me an email with it. Send me an email and say, take a look at this. Tell me the question. Tell me what answers you put in, and then I'll do it out and just verify it or do
Yeah.
something.
Yeah.
Okay?
I think you can look up what answers she put on there.
Yeah, I can. I can look up what you put in and what the answers. But I remember that. We had that. We had the.
I'll scan my notes to like the ones that we did in class.
Okay. All right. All right. This first one here says, consider the function f of x squared minus x minus 6. It says, find the equation of the secant line joining those 2 points. Okay, so here we go. Let's take a look at the graph first.
Oh, this is
No,
from,
this is the question.
yeah, this is from like section 4.3. It was like an early.
This is a mean value theorem problem. Yeah. This would be like 4.2 or 4.3 or so. Let's do a graph of this quadratic first. If you were to factor this would factor into x minus 3, x plus 2. Okay. X minus 3, so it has a 0 at 3, it has a 0 at negative 2. They're not asking you to do this. The intercept is 0, negative 6. The graph is something like this.
So when it's negative 6, it's the intercept?
When x is 0 and y is negative 6 is the y-intercept, yes. These are the x-intercepts. You set y equals 0 to find x-intercepts. You let x equal 0 to find y-intercepts. Okay. This would be the parabola. It says find the equation of the secant line joining the points negative 1, negative 4, and 3, 0. So,
I'm sorry, could you repeat the question?
question is to find the equation of the secant line joining the points negative 1, negative 4, and 3, 0. We want to find the equation of that line. Well, the equation of that line, find the slope. Slope is equal to the change in y, 0 minus negative 4, over the change in x, 3 minus negative 1. That's 4 over 4, that slope is 1. The slope of that line is 1. Next thing we have to do is find the intercept. To find the intercept, well, let's see. We know that y, we're going to put it in y equals mx plus b form. We know the slope is 1, so we know that y equals 1x, or x plus b. And what you have to do is find b. Either use this point 3, 0, or use this point negative 1, negative 4. If you use this point 3, 0, 0 for y. X is 3. Solve for b. B would be equal to negative 3. Therefore, the equation of this secant line is y equals x minus 3. That's the equation of this secant line right here. Okay? All right, then it says use the mean value theorem to determine a point C in the interval from negative 1, 3 to here, in this interval, here, where such that the tangent line at C is parallel to the secant line. So we're looking for some point in here somewhere where the slope of the tangent line, here, is equal to the slope of the secant line. That point is guaranteed to us by the mean value theorem. Okay? Mean value theorem says that there will be a C in here somewhere where f prime of C is equal to f of b minus f of a over b minus a. Well, that's what we just did. This is the slope of the secant line. Okay? We found that slope to be equal to 1. Okay? We already did this when we did this right here. All right? This is f of b minus f of a over b minus a. All right? So, we're looking for a C where the derivative at C is equal to 1. Well, the derivative at C, take the derivative of this, it's 2x minus 1. At C would be 2c minus 1. Okay? Take the derivative and let x equal c is what you're doing. That's equal to 1. We want to find the c that makes this derivative, 2c minus 1, equal to 1. We're looking for this point right here. Solve for c. 2c equals 2, c equals 1. At this point where c is equal to 1, the slope of the tangent line is equal to the slope of the secant line. Okay? So c equals 1. That's the answer to B here in this. It says find the equation of the tangent line through C. Well, let's see. We know the slope of this line is the same as the slope of this line, which is 1. We need the point here. This point is the point where x is 1, and the y would be 1 squared minus 1 minus 6. Okay? That would be a negative 6. That's kind of interesting. It's equally distant from the intercept here. This is 1, negative 6. So we're looking for the equation of this line whose slope is 1, containing the point 1, negative 6. So y equals 1x plus b. Y is negative 6. X is 1. B is negative 7. Okay, that's where it hits down here. So the equation of this tangent line right here is y equals x minus 7. Okay? And then it says graph the function, which we've done, the secant line, which we've done, and the tangent line, which we've already done. Therefore, we are done. Okay? Then she's got a bunch of things back here. Whoa, what the heck is all this? Oh. Oh, now someone's going to be, oh, you have to send one out to kill me. All right, so that's it. On the test, you get something kind of similar to that. That'll be what you get on the test. A question similar to that. Okay? Okay, any other questions? Anybody know? Where is Vitaly? I saw him today, too.
Yeah, he told me.
Everybody's slacking.
I know it.
What about that other kid? He hasn't been here.
Comes in, gets an 100 on the exam and leaves.
I don't know.
Did he get 100?
Did he? I
I
can't
don't
remember. I don't know.
All I remember is that you gave him a good sign.
I gave him a good sign.
I don't know this.
Oh, I gave him one
Or
of these.
something like that, I'm not
Must have
sure.
been really good then. All right. Let me give you some rules for graphing functions.
Sweet.
Okay? A summary of curve sketching. It's summary up there. It doesn't look like it, but that's what it is. Okay. 1. You should determine symmetry. Symmetry can be really helpful. If you have an even function, you get symmetry with respect to the y-axis, which means what? You only have to graph half of it, because the other half is the reflection about the y-axis. All right? If it's an odd function, you have symmetry with respect to the origin. If you have an even function, we have symmetry about the y-axis. If you have an odd function, you have symmetry about the origin. Okay? How do you recognize an even function? You recognize an even function if when you replace x with its opposite, you get the original function back again. That's how you recognize an even function. The simplest even functions are f of x equals x squared, for example, or x to the fourth, or x to the fourth plus x squared, or x squared over x squared plus 1. All the x's are squared. It doesn't matter if you have x is negative 3 or positive 3. You're going to square them anyways, okay? That gives you an even function. You should recognize that cosine is an even function as well from the trig functions, okay? That can be helpful. An odd function is one where when you replace x with its opposite, you get the opposite of the original function. X cubed, okay? X, okay? X over x squared plus 1. That is odd, all right? That's an odd function. Replacing x with its opposite will give you the opposite of the original function. And that gives you symmetry with respect to the origin. Damien, you okay? Do you want me to do anything? Do you want me to wait?
No, you're good.
You gonna put drops in it or something?
No, I left metal.
It's, it's what? It's metal? Is that what you said?
No, my eyes just, they dry out easily. I'm okay.
Okay, all right, okay.
Okay.
All right. Okay, the first thing I recommend you do is see if you have symmetry, because that can be very helpful in doing the graph. Next thing. Find vertical asymptotes. Where are vertical asymptotes? Vertical asymptotes occur for those x values that cause the denominator to be 0. Okay? X's that cause the denominator to be 0. Polynomial functions never have vertical asymptotes. Okay? Never. Rational expressions, one polynomial divided by another, that's where you'll find vertical asymptotes. Okay? Vertical asymptotes are a key. They determine much of the graph. Graphs cannot cross vertical asymptotes. What happens is graphs will either go to positive infinity or negative infinity as they approach a vertical asymptote. Okay? Vertical asymptotes are important. You should also notice any horizontal asymptotes. You find horizontal asymptotes by taking the limit as x goes to infinity of the function. If that limit exists, we have a horizontal asymptote. Y equals that limit would be a horizontal asymptote. And as well as the positive infinity, you should do negative infinity, although on our graphs, they're going to be the same almost always. There are functions where the asymptotes, horizontal asymptotes may be different, but we don't do any functions that complicated, okay? So, horizontal asymptotes, one thing about horizontal asymptotes, graphs can cross horizontal asymptotes. Horizontal asymptotes tell you the behavior of the function as x increases or decreases without bound, okay? As x goes to infinity or negative infinity, what's going on with that function, okay? Next. You should be able to find out where the function is increasing and decreasing, where the graph is rising or falling, and that is the first derivative. Find where the first derivative is positive, the graph is rising. First derivative negative, where the graph will be falling. And where the first derivative is equal to 0, very important, horizontal tangents. And what I would recommend you do, once you find the x values that cause that first derivative to be 0, substitute those x values into the original function to find the y values.
That will give you the point of where the horizontal.
That is exactly right. That'll give you the point where you have a horizontal tangent, okay?
Plug those values.
Yes,
into the
yes.
original function.
Substitute back in. And that will give you the point where you do have a horizontal tangent, okay? Fifth. Oh, okay.
I was getting confused on that.
We're going to do, I got a couple examples I want to do. We'll do 3 examples. You okay, Damien? Oh. Okay. Number 5. Number 5, find the second derivative. Greater than 0, the graph is concave up. Second derivative less than 0, concave down. Second derivative equal to 0, you have a possible point of inflection. Okay, because it's possible to have a second derivative equal to 0 and not be a point of inflection. To be a point of inflection, the second derivative will be 0, and it will be transition between concave up and down. Okay, it has to be transition between up and down. Okay. Those are the steps I think you should take to do the graphs of any of these. Yes?
Again, do you plug that value into?
Yes. Yeah. Yes. I'm going to write that down. Good call. Substitute back into the original.
In order to get the point of.
Inflection. Yes. Okay. All right. I have 3 problems I made up to illustrate this, which you will get on the test. I'll tell you right now. You're going to get a cubic polynomial on the test, and you will get a rational expression. Okay? So let's start. Let's do this one.
This is everything you've done, right?
What's that?
This is everything you've done.
Yeah, that's it. Yeah, this is essentially the whole chapter so far. Like I said, what we'll do on Monday, we'll do the max-min problems. We'll take a look at the differentials too, but the max-min problems are the last thing to do. We'll do that on Monday. And those are pretty simple, and we'll do those on Monday. All right, let's do first example. Let's do this one, y equals x over x squared minus 1. And we will do it. All right, let's take a look at this. First of all, what kind of a function is this? It's not even, I know. The whole semester, every time I asked the question, the answer was even. Not even, though. All right, this one's not even. It's not even because that x in the numerator is not x squared. If that had been x squared, it would be an even function. But because it's just plain x, this is going to be an odd function. Okay, this function is odd. Watch this. If you were to do this, if you were to write it this way, and replace x with its opposite, this is what you would get. You would get the opposite of the original function. You'd end up with this, which is the opposite of this. Okay? All right? Now, I'm not going to ask you if the function's even or odd, okay? I'm telling you this as an aid in doing the graph of these functions, okay? This will be a helpful aid in doing the graphs. You can know, if you do the graph of this thing based on your first and second derivatives, and you don't get the symmetry with respect to the origin like you know you must because it is odd, you know something's wrong, okay? All right, what kind of symmetry do we have with this odd function?
Symmetry about the origin.
About the origin, that is correct, okay? So we know we have symmetry with respect to the origin. That can be helpful. All right, so origin symmetry. I'm going to write that down. Origin symmetry. Now, let's look at asymptotes. Let's look at vertical asymptotes. What do we have for vertical asymptotes? You bet we do. Take the denominator, set it equal to 0. Factor it. Set each factor equal to 0. We have 2 vertical asymptotes.